everyone, here is some help with making esters that are a little bit different than just your straightforward carboxylic acid, alcohol shoved together make an ester. These ones that you have to think about just a little bit. So here we have an example, and this time you have the carboxylic acid and the ester all on the same compound. And for this one, there'll be something in the question that says you to make a cyclic ester. So what happens is, as you know, and I've seen some of you sort of circling and highlighting the water molecules that come off, which is a great idea. So these are the things that come off here. So I'm going to circle them. And of course we make the water, which I'll put over there. So here we have the rest of it that's going to form the cyclic ester. Now it's a good idea for this one to number your carbon atoms, and of course that oxygen there becomes part of the chain as well. So this bit here sticks out. So we've got 1, 2, 3, 4, 5. So as I said, this carbon double bonded to the O isn't part of the cyclic chain because that bit actually sticks out to make part of that ester link. That's the other end of the ester link that's going to link onto, so that's part of the chain, the oxygen that's on here. It doesn't really matter whether it's this hydrogen and all of that and you use this one as the O link, or whether you take off this oxygen and hydrogen and that hydrogen, that's part of the O link. It makes no difference, you end up with the same thing. So please don't worry about that. So we've worked out that it's a 5 carbon and oxygen cyclic thing. So it's going to be, oh sorry, I can't count, I've missed one here. So it's going to be a hexagon because you can see there's 6, that's a 6. Let's just change that. So there's your hexagon. So carbon number 1 is here. That's got the carbonyl chain on. Then I'll go for 2, 3, 4, 5. I'm not going to bother naming any of the ones in the middle because there's nothing really exciting about them. And on the number 6, that's going to be your oxygen. So that's how you do a cyclic one. That was something a bit like one of the ones in the question. In fact, I think there were 2 questions in the homework pack, which a couple of people did struggle with. Some of you got there, which was brilliant. So well done if you did. Next one. Sorry, will I go away? So here we have, that was my cat, sorry. Here we have another one, and it's again where you've got a carboxylic acid and an alcohol within the same chain, but this time I've moved the alcohol rather than being at the end here, but you work it out the same way. So let's highlight those bits that we're going to pull off to make the water, and then let's start numbering. 1, 2, 3, 4. Try and do this without rubbing it out. 5. So there we go. The 5 is the oxygen. So you can see on 4 there's a little methyl group that's going to stick out. That although it is part of the chain, it's not part of the chain that's going to form that cyclic ester, because you go from here, the carbon with the carbonyl group on it, all the way through 2, 3, 4 up to the H, to the oxygen that's got the alcohol H on it. So this time it's a pentagon. So carbon number 1 has the C double bond O on it. 2 and 3 aren't doing anything exciting. That's 2 and 3. I'll number them so you can see. Number 4 here has that methyl group on it there. And then 5, of course, is going to be the bridging O. So with this one here, it's more or less the same, but this time there's just a little sticky out bit. So there's a methyl branch on there, on carbon number 4. And instead of it being a hexagon, it's a pentagon. But it's the same process. But it really helps if you number it and you look for how long that chain's going to be when you do these cyclic ones. Here I have the last example, which is carboxylic acid and an alcohol. But this time the alcohol is not at the end, it's not a primary, it's a secondary alcohol. So it just makes it slightly different, so you understand how this affects it. So it's not a cyclic one, it's a straight chain one. So let's get that ester group in there. So the carbon double bonded to the O is this one here. You can see there's 1, 2, 3 carbons in that chain. There's number 1, 2, and then 3. So that's carbon number 1, 2, 3. On this side, you've got that O there. So let's circle these waters again. Let's put that down there because there's no room. So you can see that's that one. That's your bridging O. Attached to that is a carbon. And you can see there's 1, 2, 3 in a row. So 1, 2, 3. So let's number these. So I'm going to number the bridging O just because I did in the other examples. And you're looking for that longest chain. So that's your bridging O. 2 is this carbon here, which has got a methyl group on it. This is number 3. That's number 4. And on 3, there's another methyl branch there. So you can see O, bridging O. 2 and 3 have each got methyl groups, and 4 is just the end of the chain. It just changes it slightly because I think that some people often fall into the trap of just automatically putting that bridging O and then seeing it's a 4 carbon chain and then taking it all the way along, and not putting that O link in the middle of the chain rather than at the end. And obviously it's a secondary alcohol, it's not at the end, it's on position number 2. Okie dokie guys, right, so hope that helps. Thanks guys.